Hello, my name is Ryan from Buster Beagle 3D, and today I'm going to be reviewing the Makera Carvera Air. It's an affordable yet quite capable desktop CNC machine. It includes auto probing to automatically level the cutter to the workpiece. It has a quick tool change mechanism and can also be used with a 4th axis module and laser engraver if you want to upgrade the machine. You can also set up all of these jobs with the use of Makera Cam software, as well as the Carvera controller to run jobs over Wi-Fi. It's been a fun little machine to work with, but what do I think of it? And what was I able to do with it so far? Well, let's find out. As always, I wanted to thank Makera for sending me this machine for my honest review. There are affiliate links in the video description that do help out the channel if you use them, but they have no bearing on my opinion of the machine. With that out of the way, let's get started. The Carvera Air came well packaged, and my particular machine also came with both the 4th axis module and the laser engraver that I will talk about in a little bit. The kit comes with a really nice toolbox that has everything you need to attach the parts down to the build plate, and lots of bits for your different milling and engraving needs. It also comes with a bracket in case you want to mount your own tablet to the side to control the machine. I personally did all of my engraving over Wi-Fi with my computer, so I didn't use that just yet. The machine also comes with a bunch of materials and instructions for completing some projects, which not only introduce you to the capabilities of the machine, but are really good at getting your feet wet to understand just how this machine works. There is a pretty good color instruction manual, but I would also highly recommend their very useful YouTube videos that go over step by step how to make the project so you have success right out of the gate with the machine. So with the machine unpacked and after making sure to switch the power to 115 for my local power supply, I started up the machine and unfortunately I ran into my first issue. I got an error when the machine tried to home right after turning it on. I honestly was not sure what was happening, but the machine was good about giving me a sound as well as a visual representation with the LEDs at the top that something was wrong. After I connected the machine over Wi-Fi, I saw that there seemed to be an error with the Y-axis homing failing. I looked under the machine and I was able to find the culprit. It seemed like when I was removing the plastic wrapping around the machine, I pulled the plastic from under, not knowing that doing so caused the plastic to catch on the limit switch. Looking under the machine, I could see a little bit of the plastic hanging down off of the machine. When I tilted the machine over, I could see that I had accidentally bent that limit switch over, so it was never able to trigger at the point that it needed while homing the Y-axis. A simple bend back to the correct position, and we're back in business. Just something to look out for when unpacking the machine. The Carvera Air seems to be a little brother to the Carvera desktop CNC machine, but don't let the reduced features from the big brother disappoint you. What I see that is pared down from the Carvera is the lack of an automatic tool changer, the integrated dust collection, and a slightly smaller work area, but at under half the price of the original Carvera, that might still be worth it to a lot of makers. You still get the quick tool changer, air assist, and external vacuum connections. You still get a 200-watt spindle with up to 13,000 RPMs, a slightly slower speed than the 15,000 RPMs of the bigger Carvera, but still pretty powerful. You get 300 millimeters of workable area on the X, or just shy of 12 inches, with 200 millimeters of area on the Y, or almost 8 inches. You also have 130 millimeters of Z height, depending on the tool you're using of course, or just over 5 inches. To start, as I recommended before, I went through some of the tutorials that came with the machine. I personally have experience with other hobby CNC machines, but since this one is slightly different, I still thought it was important to go through the tutorials to get a feel for the machine. The first project I wanted to do was this light stand. The reason I wanted to do this one first was that it incorporated a lot of different materials and different types of tool paths, so I thought it'd be a good overall test. Now, before I get into the test, I wanted to explain some slight modifications that I did to this machine even before my first test with the Carvera Air. First, like I just mentioned, the Carvera Air, unlike its bigger brother, does not have an integrated dust collection system. They do sell a standalone unit that you can hook up to the machine for this purpose, but I didn't have that. I decided to use a vacuum that I already had, but the issue with that is that the port coming out of the back of the machine is not a standard vacuum size. Luckily, the machine has been out for long enough that this issue has already been addressed with the maker community. There are many options online for an adapter to 3D print if you wanted to hook up your own vacuum, so that's just what I did. I hooked that up to my own 3D printed dust collector, and it seemed to work pretty well, or at least good enough. It doesn't mean it's going to get all of the dust and chips, but it works pretty well if you use the shorter bits. A little later, I also wanted to install an air supply, but for whatever reason, all of my air compressor fittings were 6mm and the port on the machine was 8mm. I ended up hooking up an air assist pump I had off an old laser engraver that was still 6mm, so I had to swap out that fitting as well to a 6mm to 4mm push connector rather than the 8 to 4mm that was on there. So enough of that. Now let's get into the projects. I started with the LED light board. They do give you the option to mill the PCB board with this project, or they give you an assembled board as well if you want to skip that step. I really didn't want to solder a bunch of components, so I opted for the pre-made one. So the first thing that I milled on the machine was the black plastic block for the base of the LED board. There are written step-by-step instructions to follow, but again, they're really easy step-by-step videos of those projects made by the company on YouTube, and since I'm more of a visual learner, I went with those. I'm not going to do a deep dive into the setup of those projects since I think their videos really do a great job, but I will show you the outcome of my tests. I set everything up exactly like they showed and cut the part out of the pretty thick plastic block. When you start the project, it will first tell you to load the probe onto the machine so it can frame the area that it's going to cut with the laser on the probe. The probe head will press down on the little back button of the machine to calibrate the height of the probe before it starts. It will then move over and then use the laser pointer to outline the work area. This informs you of exactly where the machine is going to work on the material. It's exactly the same as a framing function on a laser engraver. After it outlines the work area, it will move down and touch the surface to measure the height of the surface you are working on. It will then measure the number of points that you set in the software to give the machine an understanding of the true top surface of your material. After it's done with the measurements, it will move up and beep asking you to change the tool to the next bit required to run the job. After you use the quick tool change again to swap out the bit, it will once again probe the back right corner of the machine to measure the height of the bit before proceeding with the job. Even though I had the vacuum on, the chips still flew all over the place because the bit was so long that the dust shoe didn't make contact with the surface at first, but eventually it started collecting more. It turned out exactly like it was supposed to, and after a little cleanup, it was time for the next part of this project. The second part of this project was the image that I wanted to light up. The example file gives you a few different designs to choose from, so of course I had to go with R2-D2. This part required a bit change during the job, but those are super quick and easy to do with that quick tool changer. That system is far better than any I have used on my past machines where I had to untighten the collet with wrenches to swap out the tool. Again, this is something that the bigger Carvera desktop machine can do automatically, but it's so quick and easy to do with this machine, it's really not that big of a deal. The only problem that it really brings up is that if there is a lot of chip buildup against the cover of the machine, it could be a little messy when I open the cover to do a tool change. But I typically take that opportunity to vacuum up some of the excess chips while the machine waits for its next bit. It did a great job not only of engraving the R2-D2 into the surface, but also very cleanly cut the shape out in the clear acrylic. This is something that a CO2 laser can also do, but one advantage of using a CNC machine like this over a CO2 machine is that you are not really dealing with the fumes. Now, a laser would not have produced any of the dust, but I'll take the dust and chips over fumes any day. The last part that you make to complete this project, and to be honest was the part that I was most interested in, was an aluminum button that you make to turn the LED on and off. I know that a big reason that I wanted this machine was to make parts out of aluminum, so I was really interested to see how this would perform. It's a very small part, so it didn't show off anything too impressive, but it was still a test in aluminum, so I was happy to see it perform. Overall, a pretty simple but interesting project to tackle as the first one for this machine. I'm of course skipping over some of the steps for the tutorial, especially when it comes to the things like what you need to set up in the Makera controller software, but once again, that's pretty extensively explained in the tutorials online and easy to follow along with. You really don't need any prior knowledge of CNCs at all to follow along and to make them. The next project was a 3D relief of this ship scene. The CAM software that Makera makes for use with the Carvera Air can use both solid step files like something you would make with CAD software such as Fusion 360 or SolidWorks. Makera CAM also allows you to import .stl files, the same type of files you use in 3D printing, and you can use those files to generate intricate reliefs in the material or even in the fourth axis relief that I'll talk about in a moment. So that's really what is happening here. This was another example file made by the company, and I loaded it up based on the tutorials and ran it. It's very nice and detailed and gives you a pretty good idea of just how high quality of a final product this machine can produce. It was finished off with a little saw that also came in the kit, as well as a sanding block to smooth the cut-off sections. Those are the projects that the base machine will come with, but as I mentioned before, Makera also makes both a fourth axis module as well as a laser engraver for the machine as an additional add-on, which I also have, so I'll go over those as well. The fourth axis module is an attachment that will allow you to engrave 3D objects with your machine. The attachment easily installs into place right on the work table, then plugs into a port in the back top left corner. It comes with a chuck-style rotary with a NEMA 17 motor for very precise control. On the right is a tailstop to help hold your part in place. The fourth axis also comes with its own example project, so I loaded that up onto the machine and let it do its thing. The machine cut out this very detailed and intricate Egyptian head. It was really impressive to see the amount of detail that I was able to achieve with the machining process. This involved a roughing pass followed by a detail pass. The end result in this resin block was not unlike a resin 3D print in detail, and I was pretty happy with the outcome. Now, before I move on to the laser engraving with this machine, I really wanted to test out some of my own models to see if I would be able to make something useful. The example projects that come with the machine are great, but I really wanted to dive into making my own project. So keeping with the fourth axis module, I wanted to test out a model that I had previously 3D scanned. It was a model of a World Cup trophy, so following some of the tutorials from the Makera CAM software on their YouTube channel, I ran this model in the same type of resin block that I made the Egyptian head in. For my model, I ran a roughing pass with a 3.175 bit, then a finishing pass with a 2mm, and then finally a finishing pass with an engraving V-bit at 0.2mm. It turned out pretty nice, and while it was not perfect, it gave me some pretty good understanding of some of the errors that I made before I moved on to my next attempt. The biggest issue that I ran into was that I really wasn't taking into account the full size and depth of the tool head when giving me clearance on either side of the part to be cut out. The last issue was that I forgot to give myself a roughing buffer distance before my finishing pass. This meant that all of my passes went to the deepest point, even though I intended to leave some material on there before the finishing pass. I should have left a little bit of a depth allowance in the software, but I didn't. I think of it as a learning experience that hopefully I don't repeat in the future. Both this model and the Egyptian head were cut out in those resin blocks, and to be honest, if you're intending it to be resin, you probably would be far better off doing them with an SLA 3D printer, as you can have much higher detail and even more complicated designs. However, if you were doing the same thing in wood, stone, or metal, it's not something a simple at-home 3D printer can do, which is why I was very excited for my next test, which was another version of this World Cup model, but this time I wanted to do it in brass. With the learnings I had from the last attempt in resin, I made some adjustments and attempted to do the same thing in the harder material. Now, Makera Cam does come with some really nice library of settings for those bits that come with the machine. This gives you a really nice baseline to get you started as a beginner, and one of the hardest things to do is to set up the feeds and speeds of the tools for the materials you are trying to work with. Now, that doesn't mean that you can't change them, but it does give you at least a decent starting point. I did end up altering the settings, however, because I felt that they were a little slow for this next test. I changed the step down of my bit from a 0.2mm that came loaded in the software to a deeper 0.5mm step down, which really brought the make time down on the part. I ran the same kind of roughing pass on the brass, but this time decided not to have the post holding the base on the end of the trophy. I would run a pass to cut that out at the end and save time and better hold the base. After the main roughing pass, I again ran another small roughing pass at 2mm, and then finally a finishing pass at a 0.2mm V-bit. I then ran another pass to cut out the base, as well as a closer pass on the top to reduce that post as well. Already, just right out of the machine, I was really impressed with the look of the part without any post-processing work. I'm speeding up a lot of this footage that I'm showing you here, but in all, the entire part took about 4 hours to complete. I used a saw that came with the machine to cut off the little posts that I left on the top and bottom of the part. I then used a combination of some jewelry files as well as sanding blocks to really smooth out the entire piece. I finished that off with some fine steel wool that really gave this little trophy a really nice shine. After that, I completed the design with a little bit of enamel paint for the base, and it was done. I was very impressed at the quality and detail I was able to achieve with this project. I understand it's small, but this rotary could make parts with a diameter of up to 92mm or 3.6 inches and 200mm long or 7.9 inches, which is a decent size for a desktop machine. Obviously, that would take a long time, but if it can achieve the detail at this size, then just imagine what it could make with a larger model as well. I also only ever used the 3.175 bits with this machine, but it also comes with different collets that you can use to increase that size. And so it's not limited to just what I ended up using with the machine, because that's really what came in the kit. And for this review, I was only trying to use what was in the kit. But if I wanted to rough things faster with a larger bit, you can also do that with this machine. This little trophy has to be my favorite and most impressive thing I have ever made on a CNC machine. After that, I wanted to try out the laser engraver that came with my machine. Again, this is an additional add-on or feature that doesn't come standard with the base machine. It does hook up really simply with the same way that the bits do with the quick tool changer. After that, all you have to do is hook up the connector from the laser module to the port on the tool head. There is also a tube if you would like to hook up an air assist for the laser as well. The laser module is a 5-watt diode laser, so not all that strong, but could be good for fine details if you want to engrave on a part that you are making. Other than knowing the 5 watts and the 455 nanometer diode specs, I couldn't really find any other information on the laser, such as the focal height, spot size, really anything. You can use proprietary software like Lightburn to create G-code, but Makera Cam also comes with some very basic functionality as well if you don't want to use third-party software. And when I say basic, I mean basic. There is a really limited amount of functionality that you can use to create G-code for the laser engraving. They do give some image adjustment sliders for brightness, contrast, and gamma. You can also adjust the speed, power, and line interval or DPI, but without knowing the spot size, I don't know how high DPI is too high. There's also no dithering settings to choose from, and it's really what you see is what you're going to get. I still used it because I wanted to test the functionality of the machine and the software without relying on much else, but oddly enough, I could tell from the example image file G-code that came with the machine that they still use an old version of Lightburn to create that and not Makera Cam, but either way I wanted to use it. So I set up and burned my image. To be honest, it really didn't look too bad. I used 318 DPI, and it took a long time, but the image came out very nice on this MDF board. Now, the company does say that you can use the Air Assist to aid with the engraving, but all of my years of experience with laser engraving, I never use the Air Assist while engraving, but only while cutting. I also tried to cut this skull pumpkin out, but it was not able to do that, even with the Air Assist turned on. It really seemed like the laser was just not powerful enough to do that on this 3mm MDF. I instead opted to cut it out with the bit. Now, I did have 2 more big issues with the laser engraver, and that was with the smoke management and the laser safety. First, with the smoke management, there is no fume extraction system set up with this machine like a normal laser engraver would have. You could use the same setup for the vacuum that you might use for milling, but that would just pull the smoke into your vacuum and probably push it out into your breathable air. I ended up just placing one of my high-power air filters with the exhaust hose covering the port, as good as I could do to try to extract the fumes to get rid of them before they smelled up my office. The other thing is the overall laser safety. The laser module does come with some safety glasses, and I would say that you are 100% going to need them. While there is a very tiny magnetic safety shield attached directly to the laser module, it's so short and honestly covers almost nothing, so it's not really going to protect you from anything. Also, even though the front cover of the machine is slightly tinted, that will provide zero protection for your eyes with the laser. You must wear protection when using the laser, and that would apply to anyone else in the room when you're using this machine. Overall, if you don't want to get a dedicated laser engraver machine and want to be able to add logos or small text from time to time on work you are making, it's a good add-on. If you think this can replace a laser engraver machine altogether, I would caution against doing that. After that, I wanted to play a little bit more with the aluminum cutting aspect of this machine, as that will probably be a majority of what I use this machine for. I attempted to test the machine to make an injection mold for my Buster Beagle 3D injection molding machine, but I somewhat messed up on the design and used it more of a learning experience than anything else. I was attempting to make a mold of the face of that hideous Labubu plush toy, and while the surface finish actually turned out really nice, I didn't leave myself enough room for the sprue, as well as some other errors that were my fault, but again, it was a good learning experience, and creating these aluminum molds will probably be what I'll be doing with this machine most of the time. The last thing I wanted to play with, and it really came more out of necessity than anything else, was I needed more of a part for my full automatic MK4 injection molding machine that I make and sell parts for. Now, a lot of these parts I have professionally manufactured for me, but with one part I have made, I thought, why not see if I can make it myself? The particular part I'm talking about is something I send out with my pneumatic vise kit, and it's a plastic drip guard that prevents my injection mold chamber from leaking plastic between shots. It's a pretty simple plate, but when looking up the cost to have it made, it was anywhere from $12 to $16 each to be made in a quantity of 50 plus shipping and tax. So 50 of these would cost anywhere between $600 to $800 plus tax. Well, using the Carvera Air, I was able to buy some aluminum plates off of Amazon and can make 50 of these for about $70. That's a savings of at least $530 for just these parts, and maybe much more than that with tax, shipping, and potential tariffs if purchased overseas. I measured and found out that I can cut 5 of these out at one time. One more complexity of this part is that it had threaded holes in the piece. The Carvera Air can cut this with a special bit, but unfortunately the bit that I needed did not come with the machine. I needed an M5 bit, but the machine only came with an M4 and an M3. They do, however, sell the bit on their website, so I ordered it in a few different sizes, and as luck would have it, Makera has a warehouse in Georgia, and I happened to just move to Georgia, so they actually arrived in about a day. I ordered them on Saturday, and they showed up Monday morning. I set up the whole job in Makera Cam with all of the cuts, threading, chamfering, and 3D relief, and to be honest, I was pretty happy with the results. I do have a few small tweaks that I would make to it in regards to the chamfering I was trying to achieve that I really didn't need, and the 3D engraving on the tapered part, which could have been better, but these are really tweaks that I need to make in how I mill the part and not an issue with the machine itself. I really wish that I had tried one before committing to 5 of them, but now I have a much better plan for a more polished part. But either way, I was very happy with the outcome and will certainly be saving money on these parts in the future. So for my overall thoughts, this is really the most capable CNC machine that I have ever had the chance to use up to this point. I've only used a few other hobby CNC machines in the past. This one is by far the nicest and most capable one that I have used so far. The weight of the machine really adds to the rigidity needed for nice cuts, and this machine, with its cast iron base, is very solid. I almost wish there was a way to access the spindle during the job for a tool change without fully lifting the cover out of the way, because if the dust and chips are resting against the case, it will make a little bit of a mess every time you open to change the bits. There are also some slots on the Y-axis that keep most of the debris from falling under the machine, but some does still make its way out, so you want to be sure to clean that up as well. I'm also not a huge fan of the lift up and lock lid method out of the way, as it does limit the places where you can place this machine because of the need for the extra clearance. I also have experienced a little bit of the panels delaminating from the cover, which doesn't instill me with the feeling of the highest quality part, but I know that this is an improvement over the first version, and I hope they continue to think about and improve this design. I really do love the quick tool change design, as it's a huge pain on other machines and almost effortless on this one, and requires no tools at all to do it. I also like the simplicity of Makera Cam, and while I hope they do continue to improve and expand some of the capabilities of the software, it does a decent job of working for someone not wanting to dive further into something like Fusion 360. Overall, a pleasant experience using the CNC machine, and something I will certainly be using more and more in my work. So that's it. I want to once again thank Makera for sending me this machine for my honest review. If you found this content useful and decided to pick up this machine, there is an affiliate link in the video description that does help out the channel at no cost to you, but either way, I hope I was able to shed a little bit of light on this machine. If you enjoyed this video, please do give it a thumbs up and consider subscribing for more content having to do with CNC machines, laser engravers, 3D printers, injection molding, and all things maker. Thanks again, stay safe, and we'll see you next time.